A machine for the seas. For 1,500 years, the second tallest building on Earth wasn't a pyramid, it was a machine. A machine that guided ships with fire and mirrors, built by men who didn't even have cranes, pulleys, or steel. The Lighthouse of Alexandria, standing over 100 meters tall, dominated the harbor of Pharos Island. Ships approaching the city could see its blazing beacon from over 30 kilometers away, even through storms or fog. This was not just architecture. It was a mechanical marvel. Every stone, every ramp, every mirror, every lever reflected centuries of accumulated human intelligence and experimentation. Unlike pyramids, which were primarily tombs, the lighthouse was a tool of survival, a machine designed to manipulate the environment for human benefit. It was a skyscraper, centuries before steel skeletons existed, and it was built entirely by hand. The scale, foundation of a giant. Let's begin at the bottom, the base of... The lighthouse was a solid block of masonry roughly the size of a 10-story apartment building, designed to resist earthquakes, storms, and centuries of wear. Three-tiered structure, square base, octagonal, middle, cylindrical top, massive stones, weighing several tons each, were cut with precision. Some were so perfectly joined that even today, engineers study the joints for insight. Every layer was designed to distribute weight evenly, preventing collapse or tilt. This was civil engineering on an epic scale, centuries before machines could lift tons effortlessly. To put it in perspective, the base alone required hundreds of tons of cut stone and a workforce dedicated solely to laying the foundation. A single mistake could doom the entire tower. Anchoring the giant. Foundations. Building a 100-meter tower on an island surrounded by the sea wasn't easy. Workers dug deep trenches, filling them with compacted rubble, sand, and smaller stones to form a stable mattress. They accounted for tidal shifts, storm surges, and wave erosion. Stones were arranged so each layer transferred load evenly, a method that allowed the tower to withstand centuries of abuse. The foundation was effectively a shock absorber, an ancient approach to seismic engineering, ensuring the lighthouse would remain upright even after tremors. Quarrying the stone, raw power. Every ton of stone had to be quarried, cut, and transported with only primitive tools. Limestone for the core, easy to shape but heavy. Marble for decorative elements, polished to gleam in sunlight. Granite for structural strength, nearly impossible to cut without ingenuity. Tools included dolerite pounders, round stones used to break granite blocks, copper chisels hammered rhythmically to remove material, wooden wedges soaked in water which expanded inside cracks, splitting stones slowly but reliably. Workers moved blocks of up to 5 tons, each requiring dozens of men to lift, align, and adjust. One miscalculation could crush lives or destroy months of work, yet these men managed centimeter-level precision with these tools, a testament to skill, patience, and experience. Ramps, climbing without cranes. Lifting stones 100 meters high demanded ingenuity. Straight ramps for lower tiers allowed sledges to carry the heaviest blocks. Spiral ramps hugging the tower's outer walls reduced the slope for upper tiers, making ascent feasible. Timber scaffolding supported ramps while hundreds of men hauled blocks. Water poured on sand-lubricated sledges, reducing friction and turning human strength into mechanical advantage. The lighthouse rose block by block, a combination of human power and engineering. Observers at the time reportedly marveled, saying the tower seemed to grow from the ground like a living organism. Precision, fit for centuries. It wasn't enough for the lighthouse to stand tall. It had to endure. Stones were cut to extreme precision, joints so tight water could barely seep through. The base, middle, and top aligned perfectly to guide sailors along the harbor. Plumb bobs and cubit rods ensured verticality. Cords stretched across tiers acted as sight lines, verifying alignment over hundreds of meters. Each decision accounted for decades of exposure to the elements, making the lighthouse one of the earliest examples of resilient engineering. Light, the ancient spotlight. Atop the tower burned a fire, but fire alone couldn't pierce the night. Polished bronze concave mirrors amplified the light, effectively creating the world's first spotlight. Air channels kept the fire burning steadily while directing smoke away. This allowed sailors 30 kilometers away to see the beacon, even during storms. It wasn't decoration, it was life-saving technology, ensuring that the Mediterranean remained navigable even in darkness. Transport, moving mountains. Every stone from quarry to site demanded precise coordination. Wooden sledges pulled over sand and ramps, hundreds of men synchronized. Palm fiber ropes, braided to endure extreme tension, snapped occasionally under stress. Water poured on sand created low-friction tracks, allowing heavy stones to glide. Logistics were meticulous. Tools, food, water, and spare stones were staged for every day's work. The human effort was monumental, an ancient symphony of coordinated labor. Lifting, levers, pulleys, and cribbing. Vertical placement required creative mechanical solutions. Massive wooden levers lifted blocks incrementally. Cribbing, stacked timber, temporarily held stones in place while workers slid planks for adjustments. Counterweights and body weight generated sufficient force to move enormous blocks inch by inch. Step by step, the lighthouse climbed, demonstrating the earliest known use of mechanical advantage on this scale. Organization, the invisible tool. The real secret of the lighthouse wasn't stone, it was coordination. Scribes recorded every stone, tool, and worker assignment. Boats brought supplies along the Nile, timing deliveries to match daily labor schedules. Teams specialized: masonry, carpentry, rope making, and fire management. Without this organization, no amount of manpower could have built a structure this tall and precise. Human organization became the unseen scaffolding holding the lighthouse together. Sostratus's secret inscription, the human story. The architect, Sostratus of Cnidus, was ordered to carve only the king's name on the tower. Cleverly, he carved his own name into the stone first, then covered it with plaster, writing the king's name on the plaster. Centuries later, weather eroded the plaster, revealing Sostratus, son of Dexiphanes, to the gods protecting those upon the sea. This is human ingenuity and foresight, a story of legacy that mirrors the tower itself, built to last, but also to tell a story across centuries. Surviving the elements, engineering for eternity. Saltwater, wind, and earthquakes battered the lighthouse. Stones were polished and layered to resist erosion. Tiered tapering minimized sway and pressure on lower tiers. Structural redundancy allowed temporary self-support if part of the tower shifted. It stood for over a millennium, a skyscraper before steel, enduring storms and earthquakes alike. Lives behind the tower, the human cost. Hundreds of workers, artisans, and engineers labored. Families lived on Pharos Island. Bakeries and breweries sustained the workforce. Ropes were made daily, tools maintained, stones cut and polished. Every misaligned block, frayed rope, or scorched sledge could halt progress or cost lives. This wasn't just construction, it was a human machine, powered by sweat, skill, and discipline. Engineering details, mirrors. Everywhere, the bronze mirrors at the top were concave, focusing the light to a beam visible for miles. Firewood was rotated daily to prevent burnout. Air vents were carved into the top to prevent smoke buildup. The tower's cylindrical top minimized wind drag, ensuring that fire and mirrors could operate in even severe storms. This wasn't magic. It was practical physics applied with precision, centuries ahead of its time. Global context, ancient skyscrapers everywhere. The lighthouse wasn't alone in its ambition. Rome, obelisks transported for centuries, moved without cranes. Mesopotamia, ziggurats, step pyramids, massive terraces. China, terraced pagodas rising over wooden scaffolds. What sets the lighthouse apart? Verticality, precision, and functional engineering. It wasn't just tall, it performed a vital role for society. Legacy, lessons from the lost skyscraper fragments. Remain, yet influence endures. Modern lighthouses copy. Tiered tapering designs. Civil engineers study load distribution and manual lifting techniques. Architects admire the harmony between functionality and aesthetics. It wasn't just a building, it was a template for what humans can achieve when ingenuity meets coordination. Skyscraper before its time. The Lighthouse of Alexandria, a 100-meter skyscraper built without cranes, steel, or electricity, survived centuries of storms, fire, and earthquakes. A machine, a beacon, and a legacy. Every lighthouse today is a distant echo of Sostratus's vision, a human-made miracle of coordination, engineering, and ambition. We did it first, and we did it without machines.